Hello, this is Mrs. Boots, and we're going to go through our practice problems for dividing radicals. Just like with multiplying, we have outside with inside, outside with outside, and inside with inside. You also have to make sure it's the same type of radical. Square roots with square roots and cube roots with cube roots. You can take the value first. You can simplify first, or you can take the root first. Either way, it doesn't matter. On number 1, I noticed that I have the square root of 4 over the square root of 25. The whole fraction is under the radical, so I could reduce the fraction if that were possible. I could also go ahead and simplify by taking the square roots. The square root of 4 is 2, and the square root of 25 is 5. This is completely simplified. This is my answer. Let's look at number 2. It's a cube root. That doesn't matter. It has the whole fraction underneath it. Neither of those are perfect cubes, but 250 is divisible by 2. When I divide that out, I get 125. 250 is divisible by 2. 125 times. Okay, I can take the cube root of 125. That's 5. So my answer is 5. Number 3. 24 divided by the cube root of 3. Can I go ahead and divide the 24 by the 3? No, because the 3 is under a radical. However, I cannot have the radical in the denominator. So I would have to multiply by the conjugate. Well, not really the conjugate, just by the cube root of 3. Now remember, to get rid of the cube root, how many do we have to have? I have to have 3 of them. The number in front tells us. So I not only multiply once, I have to multiply twice. Now, there are 3 cube roots in my denominator. Let's do the numerator first. We have 24. Cube root of 3 times cube root of 3 is cube root of 9. In the denominator, my cube roots cancel and I'm just left with 3. Okay, you could have said that was the cube root of 27, and that's equal to 3. Now, can I simplify that? Can I divide the 24 by the 3? Yes, because they're both outside of a radical, and that is 8. So my solution is 8 cube root of 9. That is the simplified expression. Now let's look at number 4. Are they both under the same type of radical? Yes, they're both cube roots. So I could simplify it and reduce the fraction. 3 goes into 192 64 times. So I have the cube root of 1 over 64. The cube root of 1 is 1. That's awesome. What's the cube root of 64? 4. So all of my cube roots go away. I do not have to go in and reduce the fraction or rationalize the denominator. Number 5. I have radicals, both a cube root. I also have numbers out front. We can simplify the numbers out front independent of the radicals. So 7 and 21 reduces to 1 over 3. Now let's look at the cube roots. I have a cube root of 3 on top and a cube root of 9 on the bottom. And you might be saying, hey, we could have simplified that. We might have, but here's the thing. The best way to get rid of that cube root on the bottom is to multiply by a cube root. So what would I multiply 9 by to get a perfect cube? Well, if I multiply 9 by 3, that gives me 27. So I'm going to multiply by the cube root of 3 on top and on bottom so that I get a 27. So on top, I end up with the cube root of 9. On bottom, I end up with 3 times 3, which is 9. This is my solution. No, we cannot reduce the 9s. One's under a radical and the other one is not. Number 6. Both numbers are under a radical, and I could simplify them. But notice 27 is a perfect cube. How do I take the cube root of the 27? Well, that's easy. It's just 3. But what about that 6? Well, let's back up. If I split this up into the cube root of 6 on top and the cube root of 27 on the bottom, now they're separate entities. The cube root of 27 is 3. Can you take the cube root of 6? No. So we just write it down. Now, do I need to rationalize the denominator? No, we don't. We leave it like it is. Number 7. Can we reduce the 3 over 2? No. But we can reduce the 20 over the 4 because they're both under square roots. So I still have the 3 over 2 on the outside. 4 goes into 20 5 times. The 20 is on top, so the square root 5 lives on top. Do I need to rationalize? No, the radical is not on the bottom, not in the denominator, so this is the simplified solution. Number 8. I have a radical in the denominator. It's a square root. I have to get rid of it and move it to the numerator. But the denominator has 2 terms. This is where we would multiply by the conjugate. Remember, the conjugate is the exact same terms, only now we change the sign. You only change the middle sign. So it becomes negative 5 plus 3 square root 3. Now we can go through and simplify. On top, we're going to distribute that 5 to both terms. So I have negative 25 plus 15 square root 3. On the bottom, we can do our shortcut. The first 2 and the last 2. My first 2, negative 5 and negative 5, would give me positive 25. Negative 3 and negative 3 gives me negative 9. And square root 3 and square root 3 gives me square root of 9. So let's simplify a little bit, just in the denominator. I have 25 minus 9 times 3. 9 times 3 is 27. So I have 25 minus 27. That's just negative 2. So my simplified answer on top, I would have negative 25 plus the 15 square root 3 all over negative 2. Notice there are no radicals in the denominator. Number 9. Again, I have a binomial in the denominator with a radical. So I have to multiply by the conjugate. I write down the same terms and change the middle sign. So that would be 3 minus the 2 square root 5. Okay, now let's distribute and simplify. So on top, 2 times 3 is 6. 2 times 2 is 4 with the square root of 5. In the denominator, we're going to use our shortcut. First 2 and last 2. My first 2, 3 times 3 is 9, minus 2 times 2, which is 4. 5 times 5 is 25, so that's the square root of 25. Let's just simplify the denominator. Square root of 25 is 5, so this becomes 9 minus 4 times 5. 4 times 5 is 20. 9 minus 20, which means negative 11. So my simplified answer, the top stays the same. 6 minus 4 square root 5 all divided by negative 11. Number 10. I have a binomial in the denominator that includes square roots. So once again, we multiply by the complex conjugate. No, not complex. That's got i's. Just the plain old conjugate. I copy down the terms and change the middle sign. So it's square root 3 minus 3 square root 2. Make sure you multiply by the same thing, top and bottom, so we don't change the value of the problem. Now on top, because I have one term, I can distribute that one term to both terms in the top. So negative 6 would actually stay on the outside because we don't multiply into the radical. But negative 6 times 3 would give me 18 with my square root 2. Now let's do the denominator. Again, we can do the shortcut. First and last. So, square root 3 times square root 3 is square root 9. Minus 3 times 3, which is 9. Square root 2 times square root 2 is 4. Square root 4. Now let's simplify the bottom. Square root of 9 is 3. That's minus 9 times the square root of 4, which is 2. So I have 3 minus 18. That would be negative 15. So my answer is negative 6 square root 3 plus 18 square root 2 divided by negative 15. We can reduce. All of those are divisible by 3. All of the numbers in front. Let's go ahead and do that. So that becomes negative 2 square root 3 plus 6 square root 2, all divided by negative 5. This is the simplified answer. Number 11. Okay. Now I've got two binomials. One on top, one on bottom. Well, the top one doesn't matter. We're just going to leave it alone for right now. Focus on the one in the denominator, because the denominator is where we can't have the radicals. We want to multiply by the conjugate. So we write down the terms. 4 square root 5, only instead of plus we're going to have minus. 3 square root 2. Multiply by the same thing, top and bottom. Now yes, it's going to get a little bit tricky because we have to double multiply on top. We can't just distribute. Okay, so we have the 3 being multiplied with the 4 square root 5. So 3 times 4, which is what? 12. So we go with 12 square root 5. And then 3 times 3 is 9. So I have 9 square root 2. Now, the second term. 4 times 4 is 16. So I have 16 square root. Multiply that. 3 times 5 is 15. Second term. 3 times 4 gives me 12. Negative and negative make positive. 3 times 2 is 6. I'm not going to be able to combine any of those because all of my radicals are different. But that's okay, because I can still do the denominator. The first two terms. 4 times 4 is 16. So I have 16. Square root 5 is square root 25. Now the second two terms. We're going to subtract 3 times 3, 9. 2 times 2 gives me square root 4. I wrote it down at the bottom so I could just write the number underneath once we simplified. So this becomes 16 times 5 minus 9 times 2. 16 times 5, that I believe is a large number. What is it? 80 minus 18. That gives me 62. Now I have an odd number and I have even numbers, so we can't simplify that. This is the answer. It's ugly, but it's the answer. Number 12. Again, I have two binomials, one on top and one on bottom. Don't stress about it. Look at the bottom binomial. The radicals are all square roots, so we multiply by the conjugate. The terms remain the same. Change the sign in the middle. That's the conjugate. So it's 4 plus square root 5, top and bottom. Now we can distribute, multiply. On the top, I'm going to multiply that square root 5 first. So I have 4 square root 5. Then I have the square root of 25. Now let's do the second term. Second term, I'm going to have 8 square root 2 plus 2 square root 10. Now we can do the denominator. Same shortcut. First 2, last 2. The first 2, 4 times 4 is 16. Minus 5 times 5, that's square root 25. So this becomes 16 minus 5. Well, that's 11. Can we simplify anything up there from the numerator? Actually, we can. So let's do that before we write in our denominator. I have the 4 square root 5. I can take the square root of 25. That's 5. Plus my 8 square root 2 plus my 2 square root 10. All of that is over 11. And this is my answer. Number 13. Get rid of the radicals in the denominator by multiplying by the conjugate. Change the middle sign every time. So I have square root 7 minus 2 square root 3. I know there is a binomial on top, so distribute. 1 times the square root of 7 is square root 7. 1 times 2 is negative 2 square root 3. Not a big deal. Now the second term. Minus 2 square root of 3 times 7, which is 21. Now the square root 2 square root 3, and 2 square root 3. That becomes plus 4 square root 9. Is there anything we can simplify before we move on? Yes, let's do that. Square root 7 minus 2 square root 3 minus 2 square root 21 plus, and this becomes 4 times 3 because 9 square rooted gives me 3. Now let's do the denominator. 7s and then the other 2, the 2 square root 3. So square root 7 times square root 7 gives me square root of 49, which equals 7. My second term, I would have 4 square roots of 9. That's 4 times 3, which is 12. So I have 7 minus 12, which is negative 5. So my solution is the whole thing on top divided by negative 5.